Hey everybody, this is 8.5. This is properties of logs. So basically what we learned in this section are the ways we can break logs down and sort of change them in different ways and make them easier on ourselves so that we can use them as we go. So there are a couple of important properties in here to pay attention to. The first is log base b of 1 equals 0. Basically, that's just the opposite form of the idea that anything to the power of 0 is 1, period. The second is that log base b of b, if the base and the word that I'm losing right now, match, then the exponent is 1. Here's the exponential form. If I have log base b of b to a certain power, the argument, if the argument b raised to a power p is equal to p on the other side, then they have to match, okay? Because p is the same exponent in both places. And then the final thing is if I have some sort of b to the power of log the same base of x, it equals x. Basically, if we switch that back into log form, it sets them equal to each other. This looks strange, but in practice, it's handy to have in mind because you'll go like, oh, yeah, I see that. It helps us simplify things. So, for example, we're going to simplify what's right here. Log base 8 of 8 as an exponential form would just be 8 to a certain power gets me 8. Well, x has got to be 1. So this has a value of 1. Log base 8 of 1 means basically something to some power gets me 1. Anything to the 0 power is 1. So it's got to be 0. So that's got a value of 0. So 1 plus 0 equals 1. Finished. That's it. Okay. Try another. So this one says log base 10 to the power of log of x plus 2. Remember, when there's no base on the log, the base of 10 is implied, right? So if we rewrite this, we can think about 10 to the x, right, equals log of x plus 2. So if we knew this rule that log base 10, okay? So we could rewrite this, okay, as, remember, if we go back to this rule, this is what we had here. Base, log of the same base of x, base, here, log of the same base of x, over here, equals this. So in this case, when all is said and done, this is going to simplify down to x plus 2. That's it. All right, let's try another. This one says log of a half, log base half, of a half to the power of x. The rule we're going to use here is the one that said log base b of b to the power, oh, that should be a p, equals that power. Okay, so I have base is a half, power is x. Well, the power is going to be x, so this is going to be equal to x. You try these, see what happens. Try into the discussion if you can't get them, but when you work them through, this first one should turn out to be 1. The second one should be a 7, and the third one should be a C. All right. So there are some properties here that are really important to us. We just looked at the first 4, okay? The others are the product property, the quotient property, and the power property. Basically, these let us stretch log statements out if it helps us or contract them. So what the first one says is if I have log base b of x times y, I can break it up into log base b of x plus log base b of y. As long as the base is the same in both places, multiplication implies that I'm adding the logs. Okay, I can take logs that are added and turn it into one log with multiplication. I can go either direction. A quotient, x divided by y, implies subtraction. So if I have log base b of x divided by y, it implies log base b of x minus log base b of y. Notice that the order here matters. The denominator is what's being subtracted away. The last rule is log base b of x to a power. What happens when I simplify is I get to pull that power to the front as a multiplication. So what it really says is p times log base b of x. I can rewrite that exponent as a multiplication. This, again, will make more sense once we use it. So this is, first off, I see some, you got to think about what you see here. I have x times y to the third over z squared. So I see a multiplication, I see a quotient, and I see a couple of exponents. So I'm going to use all of those rules. It says write the expression as a sum or differences of logs. This means that I want to expand. Okay, so my log base 3 I'm going to use. I'm going to start from the top down. Log base 3 of x is being multiplied by log base 3 by y. So I'm going to write that as a plus sign. And I'm going to do the exponents left. I'm going to do one thing at a time. Okay? It's being divided by z, so that's a subtraction. Log base 3 of z, oops, that should be a squared, and the y should have a cubed. I just got excited about the subtraction. Okay, so this is the first step. I expanded this. Now I have to deal with the exponents, so I can't leave them that way. So log base 3 of x plus this one comes to the front. 3 log base 3 of y minus, so does that one, 2 log base 3 of z. This is the expanded form, okay? Not the end of the world. It's just a matter of practice. You try this next one. Works the same way. When you're finished, you should have 2 log base 5 of a plus 3 log base 5 of b minus log base 5 of c. Okay? All right. Now let's try another one. This one is a little weird. There's a square root in there. But the thing is remember, a square root is just an exponent, fractional exponent, just not written the same way, right? So I'm going to rewrite it first with an exponent. I'm going to write it as log x plus y to the half over 10. All right, not the end of the world. Now I'm going to expand. So this is already an addition. I can't pull it apart. So I'm going to write it as log x plus y to the half. And then this is being divided, so I'm going to subtract minus log of 10. Now, remember there's a 10 implied here, right? So I have to do 2 things in the next step. First, I have to pull that exponent to the front. So I'm going to get half log x plus y. And that's just done, that piece. Log base 10 of 10, remember we saw way back in these rules, log base something of something equals to 1. So log base 10 of 10 is just going to be 1. That's finished. That's the expanded form. You can't subtract 1 from that. I don't know what it's worth. So that's what it is. All right, well, let's try this one. So I have log of a minus b squared divided by 10 to the power of half. All right, you try to work that out. When you are finished, you should get 2 log a minus b minus half. Okay? All right, drop into the discussion if you need help. You know how to do that. All right, so we are going to then take this log. We're going to do the same thing. This one works a little differently again because everything is under the radical here. So I have log base b of x to the 4th over y times z to the 3rd, all the whole thing to the power of 1/5. Okay, so I'm going to pull that 1/5 out to the front first, actually, because it is attached to this whole thing. So it's going to go way, way, way to the front. So now I'm going to ignore it. I pulled it out. Log base b of x to the 4th minus the stuff in the denominator, log base b of y y and z are being multiplied, so I'm going to add them. Minus log base b of z cubed. All right, I'm going to close my parentheses. Now I just have to deal with these exponents lingering around. So I have 1/5 log base b, 4, that goes to the front, log base b of x, minus the quantity, log base b of y, plus, bring that exponent forward, 3 log base z. Now from here, you can distribute this negative and get rid of those parentheses. You can distribute the 1/5 to everybody, okay? So what that would look like is, I'm going to make that negative, so minus, 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 and I'm going to distribute that. So it's going to be 4/5 log base b of x minus 1/5 log base b of y minus 3/5 log base b of z. Kind of ugly, but it is what it is. Our goal here is kind of to make them ugly. This is another one for you to try. Works just the same. If you need help, come into the discussion. That's why we're here. All right, I want to write this one as a single log. So what I want to do is I want to go the other direction. Instead of expanding, I want to contract to the middle. Okay, so the way I know this is okay is these are all log base 2. Okay, since they are all log base 2, that's a good thing for me. The first thing I see is 2 minuses in a row. So I'm actually going to say log base 2 of 560. I'm going to factor out that minus and make this a plus inside. And then base 2 of 7 plus log base 2 of 5. This sets me up for this being my denominator. So now I'm going to make one log, because that's the idea here, one log of 560 divided by 7 times 5. Well, great. Log base 2 of 560 divided by 7 times 5. Well, I can figure that out. You can do 560 divided by 7 times 5. 560 divided by 35. I'm just going to check my math, is 16. So I have log base 2 of 16 when that simplifies. This you can figure out, right? Log base 2 of 16. Think about it in our simplified form. Log base 2 of 16 equals something. Well, I can put this in exponential form. 2 to some power equals 16. Well, that's 4. So this whole thing simplifies down to 4. That's it. All right. The next one, you can work all the way through. Just do the same way. This one simplifies down to 3. All right. Try it. All right. We're going to do this one the same way. Single log. Okay. It means when you're finished, you should only see the letters log once. So I'm going to take it one step at a time. I only see one subtraction, so that's what goes in the denominator. So they all have the same base, 10, right? So I'm going to write my log base 10 here. And I'm going to take it one term at a time from left to right. That's going to be x, and the 2 means to the power of 2. All right? Minus the y has got to go in the denominator to the power of half. Fine. And plus 3, this is a plus, not a minus. This goes in the numerator, z cubed. If I'm feeling extra special, I can rewrite that fractional exponent as a radical. So it would be radical y. Either would be fine. Honestly, if you get to here and you leave it here, great. All right, here's the last one. This one should get rewritten as log x to the third y cube root y over z squared. All right. Make sure you can make these work. This is a really important thing to be able to do. We're going to use it as the steps go from here. Okay. All right. I'll see you in the next session.